Let's dive into ETL, extract, transform, load using Python and Snowflake. We'll be doing a full demo today showcasing how to load data into Snowflake, transform it with Python, and validate the results. Snowflake, a leading cloud data platform, integrates seamlessly with Python, especially with Snowpark. This allows us to perform ETL processes efficiently without moving data around excessively. We will use Snowpark's DataFrame API to simplify SQL-like operations. To begin extracting data into Snowflake, we start with a data source like an S3 bucket containing a CSV file. This cloud storage service from Amazon allows us to store and retrieve large amounts of data efficiently. Using Python, we establish a connection to Snowflake with the Snowflake Connector Python library. This library provides the essential tools to securely connect to our Snowflake account, authenticate, and execute operations. Once connected, we load the raw data from the S3 CSV file directly into a staging table in Snowflake. This staging area acts as an intermediate location where we can temporarily store the extracted data before further processing. To simplify data operations, we use Snowpark's DataFrame API, which provides a familiar SQL-like interface within Python. This allows us to perform queries and manipulations on the loaded data using Python code, bridging the gap between programming and database operations. Next, we'll transform the data directly within Snowflake using Python. Snowpark lets us define user-defined functions, UDFs, in Python. We'll apply these functions to clean the data, handling null values, formatting dates, and perform aggregations. Snowflake's compute resources allow parallel processing, making these transformations highly efficient. We can leverage libraries like pandas for data cleansing. After transforming the data, we move to the loading phase of ETL. This is where the cleaned and processed data gets stored in Snowflake tables for analysis and reporting. Snowpark provides the write pandas function, which efficiently loads pandas data frames directly into Snowflake tables. This method handles data type conversions and optimizes for Snowflake's columnar storage. For larger datasets, Snowflake supports bulk load commands like copy into, which can ingest data from cloud storage stages with high performance and parallelism. To keep tables up to date efficiently, we use incremental loads and change data capture mechanisms. These only process new or modified data since the last load, reducing processing time and costs. Now for the critical validation step. We need to ensure the transformed data is accurate and consistent. We can use SQL queries to compare the source data with the loaded data, verifying row counts and schema integrity. Additionally, Python scripts and libraries like PyTest can be used for automated testing and custom assertions. Snowflake's data governance features aid compliance. We'll run queries to compare source versus loaded data using libraries like PyTest for automated tests. Data cleansing is a crucial transformation step in ETL processes. It removes errors and inconsistencies from raw data, ensuring accurate analysis and reliable insights. Let's look at a specific example. Suppose we need to clean a sales column that contains negative values and non-numeric entries. The goal is to remove negatives and ensure all values are numeric floats. We can define a Python user-defined function, or UDF, to handle these operations. The UDF checks for null values, converts the data to float type, and replaces any negative values with 0. To use this UDF in Snowpark, we register it with the session. Then we apply it to the data frame using the withColumn method, creating a new cleaned column. Beyond the sales example, Python functions in Snowpark can handle various cleansing tasks. This includes replacing null values with appropriate defaults, formatting dates to standard formats, and standardizing data units or categories. To optimize our ETL pipeline, consider using Snowflake's serverless functions for Python-based ETL to improve scalability. These functions run without managing infrastructure, automatically scaling as needed. We can leverage zero-copy cloning for efficient testing and versioning. This feature creates instant copies of data without duplicating storage, allowing safe experimentation and version control. Also, explore the use of Snowflake tasks to automate the ETL workflow, scheduling the pipeline to run at specific intervals. This ensures regular execution without manual intervention. You can transform data for AI models, using Python in Snowpark to prepare data sets for machine learning workflows within the data warehouse, and use event-driven architectures via Snowflake streams to trigger ETL processes in real time, responding to data changes as they occur. We've covered a full ETL demo with Python and Snowflake, including loading, transforming, and validating data. The trend is moving towards more automation and AI-driven efficiency. Expect to see increased use of serverless ETL tools and AI-enhanced ETL, where AI generates transformation code. As of 2025, organizations are increasingly adopting cloud-native ETL solutions like Python-Snowflake combos.